The word superfood carries no formal scientific definition and has been applied liberally enough to describe everything from acai berries to kale chips to bone broth, often driven more by marketing momentum than measurable evidence. Quinoa is one of the few foods that genuinely merits a closer look on its own nutritional terms, independent of whatever label gets attached to it. It has maintained its place in health-conscious grocery carts for well over a decade, not because of aggressive promotion, but because it consistently delivers across multiple nutritional dimensions simultaneously. Understanding what those dimensions are and what they mean for different health goals helps separate quinoa's legitimate value from the noise that tends to surround anything described as a superfood. What quinoa actually is. Quinoa is botanically a seed, not a grain, though it is classified and used as a pseudo-cereal because it cooks and behaves like grains, such as rice or couscous. It is the seed of the Chenopodium quinoa plant, which is native to the Andean regions of South America and has been cultivated there for thousands of years as a staple food crop. The three most common varieties available commercially are white, red, and black quinoa, with white being the most widely sold and mildest in flavor. Red and black varieties have a slightly earthier, nuttier taste and retain their shape somewhat better after cooking. All three share essentially the same nutritional profile, making the choice between them primarily one of culinary preference rather than health outcome. The complete protein distinction. Quinoa's most frequently cited and legitimately distinctive nutritional feature is that it is a complete protein, meaning it contains all 9 essential amino acids that the human body cannot synthesize on its own and must obtain from food. This is unusual for a plant food. Most plant protein sources are limiting in one or more essential amino acids. Rice is low in lysine, wheat is low in lysine and threonine, legumes are low in methionine. Quinoa contains meaningful quantities of all 9, including lysine at concentrations higher than most cereal grains. 1 cooked cup of quinoa provides approximately 8 grams of protein. In absolute terms, this is less than animal proteins, but the complete amino acid profile means the protein is more directly usable by the body than most plant alternatives of equivalent volume. For people following vegetarian or vegan diets, or those simply reducing meat consumption, quinoa is one of the most practically convenient ways to obtain complete plant protein without needing to strategically combine multiple foods at the same meal. Fiber, blood sugar, and satiety. A cup of cooked quinoa contains 5 to 6 grams of dietary fiber, contributing meaningfully to the recommended daily intake of 25 to 38 grams. Fiber serves multiple functions relevant to both short-term appetite regulation and long-term health outcomes. In the context of a single meal, the combination of fiber and protein in quinoa slows gastric emptying and moderates the rate at which carbohydrates are absorbed into the bloodstream, which produces 2 practical effects: a steadier blood glucose profile compared to refined grain alternatives, and a more sustained sensation of fullness that reduces the likelihood of subsequent overeating. Quinoa's glycemic index is approximately 53, which places it in the low glycemic category compared to white rice at 72 and white bread at 75. For people managing blood sugar through diet, whether due to diabetes, insulin resistance, or general metabolic health goals, this lower glycemic response makes quinoa a more appropriate grain substitute than most refined carbohydrates. The fiber also supports gut microbiome diversity and regularity, both of which have documented relationships with systemic inflammation levels and long-term metabolic health. Micronutrients: magnesium, iron, zinc, and B vitamins. Quinoa's micronutrient density distinguishes it from many refined grains that deliver calories with minimal accompanying nutrition. A cup of cooked quinoa provides roughly 30% of the daily value for magnesium, a mineral involved in over 300 enzymatic reactions, including blood pressure regulation, glucose metabolism, protein synthesis, and muscle and nerve function. Magnesium deficiency is common in Western populations and has been associated with elevated cardiovascular risk and impaired insulin sensitivity. Iron content in quinoa is approximately 15% of the daily value per cooked cup, in the non-heme form that is less readily absorbed than heme iron from animal sources but meaningful as a contribution to overall iron intake, particularly for vegetarians. Zinc, important for immune function and wound healing, represents roughly 13% of the daily value. B vitamins including folate, thiamine, riboflavin, and B6 support energy metabolism, red blood cell production, and neurological function. This micronutrient breadth makes quinoa substantially more nutritionally complete than white rice, pasta, or bread, which provide comparable caloric energy but far less accompanying nutritional value. Antioxidants, quercetin and camphorol. Research published in the National Library of Medicine identifies quinoa as a rich source of the flavonoid antioxidants quercetin and camphorol, two compounds extensively studied for their anti-inflammatory and cellular protective effects. Quercetin inhibits inflammatory enzyme pathways and has shown antiviral and antihistamine properties in laboratory research. Camphorol is associated in observational studies with reduced risk of chronic diseases, including certain cancers and cardiovascular disease. The concentrations of these compounds in quinoa exceed those found in many commonly consumed fruits and vegetables, adding an antioxidant dimension to quinoa's nutritional value that complements its macronutrient and micronutrient profile. Naturally gluten-free and environmentally resilient. For people with celiac disease or non-celiac gluten sensitivity, quinoa provides a safe, naturally gluten-free grain substitute that does not require the processing and formulation that many commercial gluten-free products depend on. It can function as a direct substitute for bulgur wheat, couscous, farro, or barley in any recipe, without gluten-free reformulation compromises. Quinoa plants are notably hardy, tolerating poor soils, high altitudes, frost, drought, and salinity conditions that would destroy most conventional grain crops. As agricultural systems adapt to shifting climate patterns, crops with this resilience profile attract increasing interest from food security researchers. Before cooking, quinoa should be rinsed thoroughly to remove saponins, naturally occurring bitter-tasting compounds in the outer coating that can cause digestive discomfort in larger amounts. Most commercially sold quinoa has been pre-washed, but a rinse under cold water for 1 to 2 minutes before cooking is standard practice. It then cooks in approximately 15 minutes at a 2-to-1 water to quinoa ratio and keeps well refrigerated for 4 to 5 days, making it practical for weekly meal preparation. No single food transforms a diet, and quinoa makes no meaningful difference if it appears occasionally in an otherwise nutrient-poor eating pattern. Its genuine value is as a reliable, versatile, and consistently nutrient-dense anchor in a varied whole food diet, where its complete protein, fiber, micronutrient density, and low glycemic response collectively contribute to the dietary pattern qualities most consistently associated with long-term health.